Welcome to our second day of DecisionCAMP, everybody, and I'm really glad to introduce our first speaker, Brian Stucky. Brian is a recognized expert in decision management, and people know that if you're thinking about loan originations, you know whom to ask. This is always Brian Stucky. When we announced that Brian is our speaker, I got several messages. Great, Brian will be there. And Brian last year joined Quicken's Loan, and it would be really interesting to hear his new view from this company, from real trenches of business decision management. Brian.
Thank you, Jacob, and thank you, Sandy. Good morning, good afternoon, good evening to wherever you all may be at this in the world. I'm delighted to be here. While it's unfortunate we can't be together face-to-face in Norway, I am ecstatic that we are still able to join and take advantages of all that technology affords us, and hopefully it'll just be a one-year move for us here. Whoops, let me try that again. There we go. So as Jacob mentioned, I am Brian Stucky. I'm with Quicken Loans. I joined there almost exactly 1 year ago, and I've since made a move within the organization and have actually moved over to our data intelligence organization in what we call our rocket science group and quantitative intelligence, where we are focused in my areas primarily on artificial intelligence and on machine learning. This also turns out to be the prime location within Quicken right now for the deployment of decision models being used for a variety of purposes. So this seemed like a very good and very natural fit for me, and I've been couldn't have been happier with the move to go over to Quicken. As Jacob mentioned, I have been involved heavily with the mortgage world and financial services. Although my background is technology, for over 20 years now, I have been really focused in this particular world. I also am part of MISMO, which is the Mortgage Industry Standards and Maintenance Organization. This is a part of the Mortgage Bankers Association that is comprised of mortgage industry experts from a variety of fields that initially started with coming up with a data standard for loans and have expanded well beyond that. And we now have a decision modeling community of practice within MISMO that I am co-chair of. And in fact, last year in March, we announced that DMN was the officially supported and recommended standard for decision management in the mortgage industry, and work on our strategic planning group and also on the education committee. A lot of good overlap in the work that we're doing there and the work that I think is really relevant for this conference. I should mention a note about Quicken, since I know we have a very international audience here. Certainly if you're in the US, you've heard of Quicken Loans and Rocket Mortgage. We are the largest mortgage lender in the United States, with approximately 10% of all originations coming through us. Between 2013 and 2018, we did close nearly $500 billion in mortgage volume. So we have a lot of volume, a lot of loans, do a lot of work there within our organization. So if you were here yesterday when we had our panel, on the practitioners panel, you might have heard me mention this particular equation. And this was presented to us from a Mike from Forrester last year during a keynote at this conference. ML plus MO plus DD equals AI. And that machine learning, mathematical optimization, and digital decisions together are how we can actually get to artificial intelligence. We have three very powerful techniques and approaches on their own. Together, they can get us even a little bit further. Last year, Red Hat and Matteo, I believe, presented the idea of predictive decision automation and talked about the PMML function within DMN to allow you to integrate analytics within a model. And I think that is something that has been a little understated today. We'll probably see get a little bit more popular as we move forward. But I wanted to talk about moving beyond that a little bit. And interestingly enough, this really drove from a fairly innocuous bit of research at the end of last year. Quicken has quarterly hack weeks where we take a week off and we can go work on something cool, something interesting, something novel that we would like to approach that's sort of out of our normal tracks. And I got a data scientist and did a little bit of work on explainable AI with DMN. And then it turned out that there were 4 or 5 other Hack Week experiments that were all related to explainable AI or algorithmic bias and related topics. And we kind of started a tidal wave of activities and coalescing all of these efforts together. So what we'll talk about today, about how this one experiment blew up into really a larger scale look at how we are managing and ensuring the validity and compliance of our predictive models and using some DMN techniques across the board as we are doing this. I would like to give a couple of quick acknowledgements here, and actually just an outright plug for this particular conference, because over the last couple of years, it was presentations and discussions by these individuals that motivated a lot of the work that I'll be talking about here. Sylvie with her work on explanation, and I hope you got to hear her presentation on that yesterday. Denny from Trisatech and his always interesting presentations and some of the first notions about DMN representing a method to have explainability within AI. Ron Ross last year that talked about rule enforcement levels and some ideas of governability of rules. And Jan Purchase and his discussions around black box analytics in DMN. And in particular, I would like to thank him for being so willing to share some time with me and exchange some emails and some of the ideas that I was coming up with and wanted to toss around him. And it's great to have assets like that. And all 4 of these really kind of helped, and you might see some of the reflections of what they've discussed in what we will talk about here today. Our whole idea here is really this concept of trust before intelligence. At Quicken, we've got a number of isms and general ways of thinking and doing that shape how we work every day. And one of those is to do the right thing. And I think that really falls in wonderfully with this idea of trust before intelligence. And as we move forward, we have to do everything around machine learning and around AI in a very consistent, transparent, and secure way. And that's going to include establishing methods and procedures to monitor and explain what can be fairly complex analytic models. I believe Microsoft, in a report they had on AI, said that companies which implement an ethical framework for their use of AI are outperforming those who do not. So not only is it a very important thing, but I think it's one that brings a lot of value. And we get into this whole idea of ethics and what does ethics possibly mean to us here. And I think, you know, this is a rather interesting topic as this comes up, and when you hear it discussed, it is mainly in things that we should be doing around what we have with AI and not necessarily what ethics means, but in this case, it is the context of fairness and how we are handling, say, all of the data for the models, having an ethical purpose behind what the models are doing. Machine learning and AI techniques give us a lot of power, but we want to make sure we wield that power appropriately. Disclosure, being able to present and accurately show what we are doing to all of the relevant parties. And then lastly, the idea of governance. And this is really what our primary focus here. How do we manage and handle this particular work as it is ongoing? And one of the things that's been interesting in Quicken, and I probably here should make another outright acknowledgement to James Taylor, and frankly, you could probably acknowledge him on every presentation and slide that I do, but the idea of actionable insights. I don't think this is a concept within Quicken that was as explicitly called out. Our data scientists are fantastic. We have some amazing and brilliant people and generating fantastic insights from it. But taking that next step to make use of that decision in all the appropriate ways and attack what we should be is maybe something that was being cast aside. It was happening, but not called out. And this is one of the things that I think we're starting to move towards. Decision science, you certainly see called out explicitly at places like Google, and it's something I'm trying to really bring to the forefront now within Quicken. Take the analytics, the data, and the models to generate those insights, but then use the insights with the rules and with the mathematical optimization to come up with something that is really actionable. And one of the things that has to happen for that transition in between is to make sure that we are governed and we have some governance around that to make sure it is happening appropriately. Now, with the mortgage industry, we have a lot of regulations. And for those of you that are in countries outside of the US, your mileage may vary on how this looks. But we have stacks and stacks of regulations. I've spoken on this many times in the past. It's a wonderful application for DMN to apply all of these things. They are on the state level, they're on the federal level. A lot of things we can and cannot do with loans. A whole bunch of new things that came up since the crisis in 2008. So we know what we have to do within our particular industry. What we don't really have right now are a lot of standards around AI and machine learning and their use in these industries. First, we don't have standards. There is not a particular standard for these. And I know OMG, or I believe OMG, is starting to look at the idea of some AI standards. The National Institute of Standards and Technology has put out some RFIs to try to understand how it could be standardized. MISMO is kind of looking into it, but we don't really have anything. For those of you in the EU, GDPR is putting a lot of constraints on how this work happens. We don't have that in the US. I am seeing bits and pieces of this creep in on a state level. For example, January of this year, the state of California enacted the CCPA, or the California Consumer Protection Act, which is a new level of data security and privacy and consent. It certainly echoes of what we see in GDPR. I anticipate we will see things like this happen more and more, and we will likely see it on state-by-state basis. What we do have, well, we have an executive order, and the White House in January of this year announced a executive order that was around AI. And what it basically, if you want to sum it up, it was a hands-off policy. It was trying to instruct federal agencies to minimize rulemaking related to AI businesses, saying we don't want to restrict anything, we don't want to stifle innovation, so lay off whatever you do. So kind of going the opposite way. I, could argue the merits of a particular proclamation like this all day long, but that's where we're at right now. So, what does that leave us? Well, we know we've got to do some things within our general regulations in the mortgage industry, and we don't have a lot of external things to work with. I mentioned the idea of our ISM at Quicken about do the right thing, and one of the other ones we have is to find a better way. There's a whole slew of activities around data and fair lending and contractual obligation and our regular regulations that we have to do, so we kind of have to fit that in and see how it's going to apply to the predictive models as we move forward. So if you want to start at a top level here, we've got for our predictive models 3 things. We need to make them explainable in some fashion. We need to ensure that they are unbiased. And we'll talk about the ideas of protected data and proxied data here, and that we're compliant with every kind of contractual and regulatory constraint that we have out there. Algorithmic bias, which is it's an issue in financial services and in mortgage. I don't like the term of saying we're introducing bias into a system. We're actually probably reflecting bias that at one point existed, and we know it existed in the lending industry. And so it's a number of things that we can do to give us as many assurances as possible that we are not going to be suffering from a problem here. And these are things like guaranteeing fairness and neutrality, explainability, governability, and human intervention where possible. And those last 2 points are very, very critical here. Just a couple of weeks ago, you may have heard about a story that was in Detroit, which is the headquarters of Quicken Loans, where there was a robbery at a store, which is literally 2 blocks from our headquarters that I've been in, and facial recognition off of the video cameras around the store caused the arrest of the wrong person. And it happened to be a person of color, and there are some criticisms, complaints, rightly so, and worried about how that was used and what kind of bias may have been in that particular system for facial recognition. Not really what we're talking about here, but that problem is definitely out there. So what we've tried to do here is think about breaking this down into 3 levels and really use BPMN to create a framework or a permissible use process, and then utilize DMN within that at various stages to facilitate consistency, enable compliance, and ensure audit integrity. And we look at it at 3 stages. And at each of these stages, you can think of big gates for us. We've got a number of input elements, things that we're having to check, approvals, and then output elements to get us to our next step. And at the first one, we're looking at the data by itself, the data that will be used for a model, nothing else, before we get any further. When we're comfortable with that, we get into the construction of the models themselves and look at a number of other things, the methodology and how they're being built, what they're being used for, compliance and regulatory concerns. After that, there is another usage stage, which is essentially before we go to production. Last checks, whether they are from our leadership, our legal teams, and we've got an explanation component that's required here so they're able to see and understand the model. Building a process like this also lets us identify points for automation that we may not have thought of, gives us ideas of where humans will be needing to intervene on this, and we can start to think about hybrid approaches that combine the human and the automated evaluation. And this is where some of the concepts that Ron Ross presented last year come in with this idea about rule enforcement levels. You know, he gave 3 tenets about what rule tools should possibly add in terms of governing. You know, one of them was better addressing the sentiment of what the rule is supposed to be expressing, and one was about a tie-in more directly to governance. And I think we're kind of looking at both of those, and we've almost used this as a guideline, if you will, when we have a step of an approval. You know, what kind of an approval is this? Is this just a strictly automated, no alterations, done and done? Or is it one where, yeah, we can come up to a decision, but somebody has to be able to go and look at it, or primarily they're going to override that. They can get information from the automation, but that's as far as we're going to go with it. And it gets into some of the really interesting comments about human only, machine only, and human and machine hybrid activities and the kinds of things that we can do with them. So from this, we're starting to craft this a network of how we are looking at the various activities that have to go on with it. So as an example of 2 different cases at our data stage, we have outright protected data classes from a couple of agencies, from the Federal Housing Administration and the Equal Credit Opportunity Association or administration, that say these particular data attributes you cannot use. They are protected classes under fair lending. For example, we cannot use the national origin or race of an individual in decisioning, period, end of conversation. This is strictly enforced. This is not overridden in any fashion. You know, built a very simple, easy DMN model to do this. I won't bother showing it here. It's nothing too complex, as you might guess. That's an easy case. Contractual usage of data that has been acquired is a different situation. We had a fairly lively discussion at DecisionCAMP last year about legal language and what we liked and did not like about it. Mostly did not like. This gets very tricky. You can see the cases where we have explicit and implicit yeses and nos in use for the data itself or how it may be used. Some of this is fairly easy to automate, other parts are not. We are certainly always going to allow an override in this from a pre-authorized actor. In this case, our contracting people. We're not going to make that decision without their input of it, but there's a whole slew of levels that let us know what we can use. And I should caution, these are, in each of these stages, I'm just going to show a couple of examples. There's a lot more in there. One of the things that has been incredibly exciting about this effort is the buy-in we have from our legal teams, our contract teams, our compliance teams. Rather than I had a halfway expectation like, sure, sounds good, let us know if you need something. In fact, it was the other end of the spectrum, like, fantastic, I want this, we'll give you resources. And so they have been tremendous assets through all of this. And it is truly a company-wide effort, knowing the importance of all this as we move forward. So that said, go up to that middle stage, which is our model stage. And again, we've got a ton of regulations in this industry, and this is only a very, very small list that talk about what we can do under fair lending. As I mentioned previously, so many of these are perfectly amenable to applying DMN to. We can build out decision models across a variety of different regulations. Last year at DecisionCAMP, I talked about the ability to repay in qualified mortgage rule, which is a great example of this. We will be implementing more and more of these in this fashion at this stage. One of the other things we have to worry about, though, is proxy data. And if this is not a familiar term to you, this is the notion that data elements that may be very safe to use, in other words, not on that table I showed you earlier, in combination with other data elements could give you the effect of using a protected class. And an example, a real world example I'll give you here. Last fall, I was speaking with a colleague from another mortgage lending institution, a very large one, that had a vendor come in and said, we've got these new metrics, these new machine learning approaches, we will get you a 10% lift. You're going to be able to handle a lot more effectively and get rid of the bad loans. This is fantastic. You need our software. And they started to test it, and they were getting, they could see some changes with it, but then they finally went to take apart the metrics that were being used. And one of the primary features was a combination of zip code, number of dependents, and employment history. And immediately the red flags came up because those three things together are very likely going to be targeting certain ethnicities, certain races across the country. And his words to me were, fair lending would be breathing down our throats so fast we wouldn't know what hit us. This is something we have to watch out for. And it's a fascinating problem. And because it also needs to be combined with the actual usage of the model. So one of the things that I explored actually during another hack week recently was something that CFPB, which is the Consumer Finance Protection Bureau, came out after the mortgage crisis in 2008. And they have a method called BISG, the Bayesian Improved Surname Geocoding, which essentially is allowing you to submit a surname and a state and get a pretty good guess as to the ethnicity and race of the person. It's basically a pretty straightforward calculation using demographic, geographic data for populations, demographic distributions, and the surname data that they have collected. So during our last hack week, I thought this seems like a problem for DMN. CFPB has about 160,000 plus names that show the demographic breakdown for them. I collected 2017 US census data for the overall population and state populations for races. And from that, we are able to make a determination, given a name and a state, of the likelihood that they are of a particular ethnic category. So Why is this important? And I've put a graphic up here about offense and defense. We tend to do a lot, as I think many companies, in terms of defense. If we get audited, what do we have to show somebody? I want to be a little bit more offensive with that. So let's say we have a lender or banker that maybe there are some suspicions that they are biased in their lending. Looking at a history of names and zip codes, we could start to see if a trend existed here. And in fact, I actually believe this data exists down to a zip code level, so we could be even more finite with it. We could do a number of things to detect trends in bias that may possibly exist. Now, if you want to think on offense, well, maybe this is a marketing tool. Now, again, we will get into an ethical question there, but we may be able to target a geographic location in terms of what we believe a particular ethnic or race distribution could be for something. It's not something that's happening now, but that's how this could be used. For me right now, this is really more of a thought of a defensive tone. So let's get down to our last stage here. And this is the idea of explanation. And I like this idea of explainability is in the eye of the beholder. I know there was a comment yesterday about never using audit trails from rules as explanation. To me, this really depends on who the audience is going to be. And we've got to be concerned with a wide variety of audiences. Our data scientists, our leadership, our compliance officers, our contracting officers, legal, externally regulators and clients. What do they need to see? What is it that's important to them? And, you know, I would argue that it's going to be a little bit different every time we move through for every particular model we have, depending on who sees it. We know we've got a lot of uses for explainable AI to validate models and see what the focus was on. You know, are we really using the right things, or have we looked at the wrong things here, and can we use it to detect bias? That helps with debugging models, knowledge discovery, excuse me, based on what we're seeing from our processes. It's got a vast array of uses and a number of facets here. It's a nice thing to have. But for our case initially, what explains model? And if we're talking about our compliance officers for some of these activities, they want to see three things. Clearly, what data is being used. Secondly, what data combinations are being used to get a sense of this proxy notion and what significance do they have. And finally, what is the prediction being made? What does this tell us, and how is that being used? They don't care so much that it is using a random forest or a logistics regression. They want to know these things in this particular case. So we did some work starting with looking at a couple of approaches together. And I think Sylvie pointed out a couple of these yesterday. LIME, which is local surrogate model that's going to take a look and give us the sense of the attributes being used and the significance that they play to predicting or against predicting whatever the model is doing. And you will often see a graphic like this with the attributes in the green saying this contributes significantly and more heavily than this green does, and red contributing in the other fashion. And then Ripper, which is one of these post hoc global models that is, replication is not the best word, but it's giving us, it's representing the model, it's building a model to represent a model, but doing it in a different fashion. And you will get output maybe that looks like this. I mean, in these cases, the names have been changed here. In their own sense, there is some explanation here, but we can do a little bit more. So what we took out of this was a couple of things. We could take what Ripper gives us and build a very plain model like you see on the top right. We got input, we're building something, and here's the output. But that visually doesn't tell you a whole lot. But if we use LIME with this, that can aid the construction of the model. If we first use every individual attribute as an input element and not a collected, so as I say, not have a lone object, but all the individual attributes we're looking at. Let LIME tell us by the significance of an attribute that maybe that's an intermediate level that we should have. And give you, so be very verbose with it and then have a visualization here that starts to say, oh, now I can see exactly how much this attribute's getting used, and is it ever being used in combination here? Go into the decision table and get a better sense of what the values and ranges are being used with it, and even provide a simulation capability. When we first showed this for one of our more complex models in order to get some input from legal, the first comments were, okay, so tell me about this, but I got questions right away as, are we still using that attribute? Well, why is that one with here? Well, what happens if this value changes? And that is exactly what I wanted to hear. That gave the person the insight to be able to ask the questions, and with some simulation that they can do live, it's a terrific thing. Lastly, because I think I'm about out of time here, but very quickly, and we're just starting to explore this concept of boundary rules. Or sanity checks. I'm sure you all heard about the Apple credit card case from the fall, where husbands and wives, the wives found they got far less credit with an equal credit background. Apple's response, I don't know, it's what the algorithm says. We cannot have that happen. And if we are building explanation facilities with DMN in this fashion, using the decision services to write rules around those that would allow us in certain classes of models to see if we are getting outside of accepted bounds could get us to something very interesting, and maybe stop some of these or call somebody to point out, hey, do we have a problem here before it actually happens? This is something I hope to talk a lot more about next year, but early stages, but I think there are so many possibilities for what we can do. I think my time is about up here. We're doing a lot of exciting things. I'm very thankful and grateful to be associated with incredibly brilliant colleagues like all of you, and your insights have been invaluable, and I'm sure you will be getting a lot more questions from me going forward about that too. So thank you very much.
Thanks, Brian. That was great. It's I knew you were going a little bit long, but I didn't want to cut you off because the presentation was so fascinating. There's a number of questions over on Slack, so you can kind of take a look at those when you've had a chance to take a breath. And I think you really addressed in your last slide and something that Jan Purchas pointed out on the Slack channel was that the algorithms are rarely inherently biased, but they reflect the biases in the data on which they're based. And I just find that reminds me of that quote from Jessica Rabbit in the film Who Framed Roger Rabbit. And she said, I'm not bad, I'm just drawn that way. And it makes me think that, you know, sometimes we're using excuses. Like you say, it's like, oh, I don't know, the algorithm just works that way. And it's like, there has to be some level of responsibility for how that gets managed.
Yep, that's a great point.
Okay, so thank you very much. We're going to stop with you here, and then we will get ready for the next presentation.